Hey guys, welcome to our Injective Global Virtual Hackathon. I'm Bojan and I'm a tech lead at Injective Labs. And today we are going to do a deeper dive into the Injective TS and how developers can use it to build decentralized applications on top of Injective. Okay, let's dive into it. So first, what is Injective TS? Injective TS is an open source TypeScript monorepo containing packages which can be used to interact with Injective and some other various APIs from a Node.js, browser, or even React Native environments. It basically provides simple abstractions over core data structures, serialization, key management, making API requests, generating transactions, and etc. To open the Injective TS monorepo, you can visit our GitHub and even Google Injective TS, and you can find all of the source code within the packages folder. And all of these folders here are basically packages that the Injective TS monorepo publishes on the npm registry as an npm module. Then obviously you can import them in your project and use them and use all of the functionality that they offer out of the box. Before we dive into it, I'd like to mention the Injective TS wiki. I think it's one of the most comprehensive documentation written out there. You can find it on the repo itself by just clicking on the wiki link over here, and here you can find explanations, overviews, explanations of technical concepts, application concepts, examples for everything that we are going to discuss on this presentation now. So hopefully this will serve you well, and you can always reference it to see what you can use these packages for, see an example how to use them, and just see what Injective offers and how you can use it to build your decentralized application. Okay, so first let's have a package overview. Let's start with the most important package out of all of them. It's the Injective Labs SDK TS package. And this package is the SDK powerhouse. It provides easy access to data from any data source, whether it's the chain or in the chain itself or some other APIs that we have, regardless of the type of access, whether it's using gRPC or REST. And it also provides a way to easily compose messages, which we are going to discuss later on the presentation, pack them into transactions, which then can be broadcasted to Injective. Then we have the Wallet TS package. This package provides a way for developers to access different wallet providers, which then can be used within your decentralized application to prepare, sign, and broadcast transactions to the Injective to the Injective chain. Then we have the exceptions package. This package provides some exception classes that can be used to provide more context about the error type thrown from within the applications built on top of Injective. Basically, this means that when, for example, you broadcast a transaction on the chain, there's some error happening on the chain, the transaction wasn't included in a block, you get some error thrown from the chain, and this is how you parse the errors so it's more human readable to show to the end user. Then we have the networks package. This package provides a way for developers to get some predefined endpoints for accessing the Sentry nodes, various APIs, the Tendermint RPC, and etc. This is useful because as a developer, you get access to the infrastructure which runs the whole set of APIs and the Sentry node, the chain itself. So you can start developing the decentralized applications without the need to spawn your own infrastructure. We have access to testnet, to public mainnet endpoints, and etc. We have the token metadata package. This package provides token metadata information for denoms that are used on the Injective chain. We've mentioned a couple of words here that might seem unknown, but we are going to explain them a bit later in the presentation, like denoms, Sentry nodes, and etc. Then we have the SDK UITS. This package provides some abstractions and mappers, we call them transformers, which can transform the data from different data sources like the chain itself or various APIs, so it's more convenient to use them while building UIs. basically to show a human readable form of human readable data to the end user. And finally, we have the utils package, and this package just provides some commonly used utility functions and classes which developers can use while building their decentralized applications on top of Injective. Before we continue, let's discuss a few technical concepts that we mentioned, so it's easier for everyone to understand what we are talking about. Sentry node is a read-only full node running the Injective chain. A full node is a server running the chain's binary, its software, that fully validates transactions and blocks of a blockchain and keeps a full record of all historic activity. Basically, the Sentry node is used for querying the data directly from the Injective chain itself. Then we have something called Indexer API. The Indexer API is a collection of microservices which the Injective Labs team built, which serve data indexed from Injective. Basically, how it works is that we have something called event provider, which listens for all of the events that are emitted from the Injective chain itself. It processes them and store them in a MongoDB for easier access and streaming support. This is quite important because it can be less performant to query the chain directly, especially when it comes to historical data. So we store them in a MongoDB and serve them to the client, so it's easier for them to access the data using a way more performant approach. It also has streaming support, which is quite important, especially for real-time updates on the UI. Let's say you have a derivative market and you want to have real-time order book updates, and this is how you use the Indexer API to get streaming support from the MongoDB itself. So any update that gets triggered in the MongoDB, it will be streamed to the client, and you can update your application state and then the UI to the user. The Indexer API is also used for supporting historical data over some period of time. For example, this is useful when we want to draw some charts to make the UI more beautiful, and etc. Another important technical concept that we need to explain is denom. Denoms are how assets are represented within the bank module on Injective. As you probably know from other presentations before, the Injective chain is composed out of different modules. One of them is the bank module, and this is where all of the assets are stored on Injective. Everyone on Injective can transfer these assets, use them for trading, create new markets on the exchange module, participate in auctions, and etc. Depending on the origin of the denom and how it was created on Injective, we have different types of denom. Let me just open the Injective TS wiki so we can see all of them and how and what's their format. So we have denom here. We have the native denom. There's only one denom of this type. It's the INJ denom, which represents the native coin of the Injective chain. We have PEGI denoms. These denoms represent assets bridged over from Ethereum to Injective using the PEGI bridge. They have the following format. So it's PEGI and then the ERC20 contract address from Ethereum. We then have IBC denoms. These denoms represent assets bridged over from other Cosmos chains through IBC. They have the following format: IBC, then / and the hash of the denom. We have insurance fund denoms. These denoms represent token shares of the insurance fund created on Injective for the perpetual markets. They have the following format: share and then the ID of the insurance fund. And finally, we have factory denoms. These denoms are representation of a CW20 token from CosmWasm on the Injective native bank module. Basically, what we need to do is when we transfer CW20 tokens, we cannot use them, for example, to create a market on the Injective. So with these factory denoms and the CW20 adapter contract, what we do is we lock the CW20 tokens on the CW20 adapter contract and then mint them on the bank module, so the user actually has a native denom on the Injective chain to use to trade, create markets, and etc. Okay, so those are the types of denoms that we have on Injective as of right now. Then we have a technical concept called token. This is an interface, just an interface. It's a denom on the Injective chain with some meta information. The metadata includes information like symbol, name, decimals, logo for the particular denom, so developers can show to the user more than just the raw denom. And for example, if you want to show USDT, as we previously saw, it will be represented as PEGI and then the ERC20 contract address from Ethereum. And this can be quite confusing to the user. So using the token interface, you can convert this denom to have the USDC logo, symbol, name, decimals, and everything. So you show the end user a human readable denom, basically. And finally, we have something called the Web3 Gateway. The Web3 Gateway is part of the Indexer API, and it's a microservice that exposes an API to the end user with the main purpose of providing fee delegation for transactions that happen on Injective. This is how we allow the user to have a gasless trading on, for example, Helix, and behind the scenes is that the gas needed for that particular transaction is paid by the runner of the Web3 Gateway service. Alongside fee delegation support, Web3 Gateways allows developers to convert messages to EEP712 type data. This is important if you want to use Ethereum native wallets, and because the way to sign transactions on Injective using Ethereum wallets is using EEP712 type data. But we are going to see another way of converting the message to EEP712 on the client side itself without the need to use the Web3 Gateway. But just as information, you can use the Web3 Gateway to achieve the same. Okay, so let's start first by discussing about how to query data from different sources using the Injective TS packages, mostly the SDK TS. We have two main sources. The first one is the Injective chain itself, and we also have the Indexer API. And we support two ways of querying the data. First is using gRPC, and then we also support the REST approach of querying the data. We also have GraphQL support, but it's only for the PEGI bridge on the Ethereum. So you can query the deposits and withdrawals that happen on the PEGI bridge on the Ethereum contract for now. So let's see some examples on how to query the chain or the Indexer API directly. On the left side, we have the gRPC way of querying the data, and on the right side, we have the REST way of querying the data. And on both sides, we query the bank module on the chain itself. We want to fetch the balances for some Injective address on the chain. And the way to do this is we import the abstraction class from the SDK TS. And the naming convention is the following. So first is the source of the data. In this case is the chain. Then we have the way of querying the data. It's the gRPC way. Then we have the module which we are querying. It's the bank module, and the API is just a suffix. And then we instantiate the class using one of the networks that the Injective Labs networks package provides. We get the endpoints for that particular network, and we use the gRPC endpoint to query the balances, and we just log the balances. And on the right side, we have the same chain, REST, bank, API. As we can see, the only difference is the REST word here, which is just indicates that we are using the REST approach of querying the data. And here, obviously, we are using the REST endpoint for the chain itself to query the bank balances for this particular address. On the Injective TS wiki, we have quite comprehensive examples for all of the query methods that you can use for all of the abstraction classes that we have on the SDK TS. So let's have a look. Actually, we can open it from here. So let's say I want to query the just the example that we shown on the presentation. As you can see here, it's quite straightforward to query the injective address balances, and you can query a particular denom from the balances and etc. Also, it's let's see an example to query the indexer API. Let's say we want to fetch all of the derivative markets that we have on the injective chain. So we have the indexer API, and we have all of the modules here. Let's open the derivative modules, and as you can see, it's quite straightforward to fetch all of the markets that are live on the injective chain. And as you can see, the difference is the indexer instead of chain, as we saw on the previous example. This means that we are fetching we are querying the data on the indexer itself, not the chain, using the gRPC approach. And then another example would be, let's say we want to query the order book for some spot market or multiple spot markets. So let's find the example order book. So as you can see here, we have the market IDs as an array. We make the instance of the particular abstraction class. Important note here is that we are using the indexer endpoint because that's the data source that we use to query the order books. We have the market IDs which we can fetch from using the fetch markets method on the same abstraction class, and then we just pass it to the method, and then we log the order books. Obviously, you can also use streaming for the same getting the order books. Let's say I wanna stream the order books for a particular spot market, so I can click on spot, and here same approach, market IDs. These are the market IDs for that I want to establish a stream for the order books, and I just call the particular method, and I have the callback, which I can do whatever I want with it. Basically, you can update your app state, you can update the UI. Just it's up to the developer to use to basically make the callback based on their needs, and then we just call the stream function, which will establish a stream to the indexer API to get all of the order books for the market IDs that we want to. Okay, now that we've seen these examples, let's go back to the next topic, which is making transactions. So what is a transaction? State changes on Injective can be done through these transactions. Users create transactions, sign them, and then broadcast them to Injective. When we broadcast the transaction, and only after every validation is successfully passed, and these validations include signature validation, parameters validation, etc., then the transaction is included within the block, which is approved by the network through a consensus mechanism. Messages are the instructions which are included in the transaction itself to specify the state change that the users wants to do. Every transaction has to have at least one message. The messages are module-specific objects that trigger state transition within the scope of the module they belong to. We can. It's important to know that we can pack multiple messages within one transaction. On the SDK TS package, there is an abstraction class message base that we export from the package itself, and every message that we have extends this message base interface. Let's have a look about on this interface. So we have messages here. So this is the abstraction class that we have, and basically all of the messages have the same methods. Let's go through them so you know what they mean and how you can use them to build your decentralized application. So to data, this method just converts the message to a simple object representation. This can be used for logging. To proto, just returns a proto-representation of the message itself. Todirect sign converts the message to a proto-representation, which can then be used to sign using Cosmos wallets, native wallets, let's say Kepler. 2amino is the legacy way of representing messages on Cosmos native chains, and just like I said, it converts the message to an amino representation plus the type of the message. 2Web3 is the alternative for 2amino with the difference of the message path type, and this is what we use to allow the user to have fee delegation using the Web3 gateway that we mentioned a couple of slides before. And we have these two methods for EEP-7112. The first one generates the types for the message, and the second one generates the values for the particular message. And this is useful when we want to do client-side generation for that particular message to EEP-7112, which then we can use to sign on a Ethereum native wallet like MetaMask. Okay. Sorry. Besides these messages, every transaction has its context, and this context includes fees, account details like the signer of the transaction, their sequence, aka the nonce, memo of the transaction, the signatures for the transaction, and etc. The transaction on Injective has the same transaction flow. First, we need to prepare the transaction itself. This is done by packing a message or multiple messages into a transaction alongside the transaction context. This can be done both on the client side or using the Web3 Gateway API. Then we have to sign the transaction. We can sign the transaction using the desired wallet, whether that's like cold or hard wallet on the browser side using some extension, or Ledger natively, or Trezor, or any other wallets that the Wallet TS package supports, or in a CLI environment using a private key. And finally, broadcast the transaction to the Injective chain using the desired approach, whether that's like on the client side directly to the node or using the Web3 Gateway API. Before we start explaining different types of making the transaction flow, it's important to understand the accounts and / wallets on Injective, because they're a little bit different than the rest of the Cosmos ecosystem. So Injective defines its own custom account type that uses the Ethereum curve for keys. Basically, this means that Injective accounts are compatible with Ethereum, and this is why this is the reason why we can use Ethereum native wallets to sign transactions on Injective. We are quite unique in the Cosmos ecosystem, but we've designed this intentionally so we can make Ethereum users be familiar with the Injective ecosystem and easily onboard them into Injective. As you can see here, this image is taken from the Injective hub. You can use MetaMask and Ledger to connect on Injective. Okay, so first let's have a look at a full example of how you can do the whole transaction flow using Ethereum native wallets. We have a Trezor here, which you can use to assign messages on Injective. I'm going to open the TS wiki so we can have a look at the example. So using Ethereum wallet. So first, we need to prepare the transaction for signing. Just like I said before, to use Ethereum native wallets, we have to convert the message itself to EEP-7112 type data and use the wallet to sign this type data. Using the message-based abstraction that we have, all of the messages allow you to easily convert the message to get the EEP-7112 type data. So let's have a look at the example. We have some constants here: the Injective address, the signer, the chain ID, the REST endpoint, and these are hard-coded, or you can use your own for, this is just an example, right? So we get the account details. This is like the account number on the chain, the sequence, aka the nonce, we get the block details for the transaction context, and here is how we create the message itself. This particular example is using the message send message, which is a way of sending assets from one address to another on the Injective chain. And here we have this utility function, get EP7112 type data, and you pass the information that we got here, and we basically prepare the EP7112 type data for signing on using an Ethereum native wallet. And then for this particular example, we are using MetaMask to perform the sign. We ask the user to sign, and then after we get the signature, we need to get the public key for the signer from the signature itself and from the EP7112 type data. This is needed because when we make Cosmos transactions, we need the public key in base64 to as part of the transaction context to send to the Injective chain. And then finally, we broadcast the transaction. We create the TX raw, which is the standard in all of the Cosmos chains, how to create and broadcast transactions. With one key difference is that we use the sign amino sign mode. This is the legacy sign mode, which is used when we wanna sign and when we wanna validate EP7112 type data signatures on the chain itself. Then we have the Web3 extension just to signify that we are using Web3 to sign the transaction. We set the signatures and then broadcast the transaction. Obviously, this is quite straightforward. Obviously, instead of MetaMask, we can use any Ethereum native wallet here. Just replace the signing method with the method that that particular wallet exposes from their API. Okay, then we have the transaction flow using Cosmos native wallets. We are going to have a look at making the whole transaction flow using a Cosmos native wallet. In this case, we are going to have a look at Kepler as one of the most popular Cosmos native wallet out there. So let's open the TS wiki again. We have the prepare sign broadcast TX using Cosmos wallet, and as the same as we did for the Ethereum wallet, we have to follow the same flow. So first we prepare the transaction, it's the same, so we get the account details, we get the block details, we prepare the transaction, we get the public key, which, like I said before, it's important when we create the transaction raw for the Cosmos native wallets. And the way to get the public key varies from different wallets. We are going to have a look how to do it on Kepler in a bit. And then we just create the TX raw using the details that we specified before. So once we prepare the transaction, we can proceed to signing. In this case, just like I said, we are going to use Kepler. So this is a small utility function that I wrote to get Kepler, and it returns the offline signer, the accounts, and the key. And then we just use the offline signer to sign direct the sign doc that we can generate using this create transaction, which is exposed from the SDK TS. And then finally, we need to broadcast the transaction. One important note, just like I wrote here, is that if we use Kepler Leap wallets after signing the transaction, we cannot use the TX raw that we created before, that we used to sign the transaction, because, for example, the user can change the gas limit, can add a memo on the wallet itself. So we need to create a transaction from the direct sign response that we got from when we signed the transaction, and then broadcast that TX raw to the node itself. And this is how you do it using Kepler. It's pretty straightforward. You can just follow the example written here. And finally, to make developers' life easier, we have something called wallet strategy. It offers developers a way to use different wallets implementations on Injective seamlessly. This is just an illustration of how the wallet strategy works. Basically, as referenced here, you have different types of transportations, but they all have the same goal, to take you from point A to point B. And this is what the wallet strategy does. It basically offers you a way to sign, broadcast transactions and many other features out of the box for all of the wallets that are supported on Injective. So let's have a look. Let's have a look at the wallet strategy and how you can use it within your projects. Let's go back to the TS Wiki. We have it here, wallet strategy. So just like I wrote, it's exported from the wallet TS, and its main purpose is to offer developers a way to have different wallet implementations on Injective. They're all exposing the same concrete strategy interface, which means that users can just use these methods out of the box without the need to know the underlying implementation for specific wallets. This means that when you call the sign Cosmos transaction, it will use the sign Cosmos transaction on that particular strategy without you knowing how it works behind the scenes. It will just sign, for example, using Kepler, using Leap, so you don't have to care about the particular wallet implementation behind the scenes. So to start using the wallet strategy, you have to make an instance of the wallet strategy class, which will give you the ability to use different wallets out of the box. And the way that you switch between different wallets is by using the set wallet method on the wallet strategy instance itself. So for example, let's say you want to use MetaMask, you do set wallet and then pass MetaMask, and then the wallet strategy will use the MetaMask strategy to sign, broadcast, and get addresses and everything else using the MetaMask strategy. Let's have a look at the methods that the wallet strategy exposes and what do they mean. So get addresses is the method that gets the addresses from the connected wallet strategy. This will, for example, if you are connected with MetaMask, it will give you the Ethereum address connected with MetaMask on your decentralized application. If you use send Ethereum transaction, it will send an Ethereum transaction using the connected wallet strategy. And then you have send transaction, which will send an injective transaction using the connected wallet strategy. And this is useful when you want to broadcast transaction to the injective chain. You have sign Cosmos transaction, which signs injective transaction using the connected wallet strategy. This means that it will use the Cosmos native way of signing transactions, and this method only comes within the wallet strategies that are Cosmos native wallets, let's say Kepler, Leap, Cosmos Station, etc. And we have the sign Ethereum transaction, which basically signs an EP7112 type data and then returns the signature to the developer from the Ethereum native wallet. And obviously, if you call the sign Ethereum transaction from a Cosmos strategy, then it will just throw an error because it's not possible to sign EP7112, let's say, using Leap. And then we have some utility functions like get public key, which gets the public key for Cosmos native wallet strategies. For Ethereum wallet strategies, it's a bit different because they do not expose this method, so you have to get it, let's say, from the signature and the EP7112 type data that you are signing. Get network ID, get chain ID is basically to get the Ethereum network ID and chain ID. We don't use these, but they're there just for your own convenience. Get Ethereum transaction receipt is a way to check whether an Ethereum transaction is included within the block on Ethereum itself. And get Web3 is just getting a Web3 instance. So let's have a look at an example usage. Here we are going to use both Ethereum and Cosmos native wallets. If you want to use only Cosmos native wallets, you can just omit the Ethereum options and you are only going to be able to use Cosmos wallets, let's say Kepler, Leap, Cosmos Station, etc. So just import it from the wallet TS. These are the RPCs. If you want to use Ethereum native wallets, you have to pass RPCs. In our example, we use Alchemy. You can use Infura or whatever you want. And then, for example, we can get the addresses using just a simple method call as shown here. So wallet strategy get addresses, and it will fetch the addresses from MetaMask because that's the default wallet. So let's say you want to change to Kepler, you can do wallet strategy dot set wallet Kepler, and then when you call the same address again, same method again, it will fetch addresses from Kepler. And yeah, just an example here to how to sign transaction using the wallet strategy. Okay, and finally, we have something called a message broadcaster. This is the final abstraction to make your life easier, to make your developer experience even better. This does prepare, sign, and broadcast using a single method call. Just like shown here, we know that devs love abstractions, but they hate implementation. So we have this message broadcaster, which will allow you to do the whole transaction flow just using one single method call. And let's go back to the Injective TS wiki, so we can have a look at the message broadcaster. So it's here, transactions, and then prepare, sign, broadcast, TX using message broadcaster. Go back, and just like it's written here, it's an abstraction class to broadcast transaction with ease. With it, you can just pass a message or messages that you wanna be packed into a transaction and the signer address, and then the message broadcaster itself will prepare, sign, and broadcast the transaction. There are two ways of using the message broadcaster. The first way is the recommended way when you are building UIs, is using the wallet strategy itself, which we just discussed in the previous slide. This message broadcaster is used alongside the wallet strategy, and to instantiate and use the message broadcaster, you can just use the following code snippet. Basically, just import it from the wallet TS, and then as you can see here, wallet strategy is instantiated from the step before. You can reference even on the wiki itself, and then you create the message itself and then just call the broadcast method on the message broadcast client. You pass the messages and the signer itself, and the message will be packed into a transaction, signed, and then broadcasted to Injective. Quite easy, huh? And then finally, we have message broadcaster with private key. This is something that mostly people use in a CLI environments. If you want to build bots or something, you can just pass a private key hash or private key class from the SDK TS. Here it's the SDK TS, not the wallet TS. The message broadcaster with private key is exported from the SDK TS. And just like the example above, you are creating the message and just passing it to the broadcast method and pass the signer itself, and everything will be done behind the scenes for you. So that's about it. Thank you for listening. If you have any questions, feel free to send me a DM or use any of the builders chat that we have on Discord, Telegram, and yeah, obviously make yourself comfortable at the wiki. We've built it for developers like yourself, and if you have any questions or suggestion, feel free to reach out. Peace.